Hi, my name is Matt, and today we're going to talk about 3D compositing in Fusion within DaVinci Resolve. The main difference between 3D compositing and 2D compositing is that we'll use Fusion's 3D environment and a specific set of tools that are designed to work in that environment. When you're compositing live action footage in a 3D environment, you'll almost always need a virtual 3D camera that replicates what was filmed on the day with a real world camera. That virtual 3D camera will allow us to render objects placed in the 3D environment in a way that matches the real world camera in terms of perspective, camera motion, and depth of field. So let's go ahead and look at our footage and get started. So we're playing this back, and what we want to add into this shot is a pirate ship over here and do a couple other refinements. The first thing I see when I look at this shot is that the camera is moving through space, and that tells me that this is going to end up being a 3D composite because I need to recreate that camera motion for any of the objects that I'm going to place in the scene. So let's go ahead and get to the Fusion page and get started. First thing I'm going to do is I'm going to go ahead and just go to a single viewer here by clicking that button. And then I'm going to rename my media in node using the function F2 button to bring up the rename pop-up. And I'll just name this element plate. I'm going to need a 3D camera to really do anything. But even before getting the 3D camera, I need to actually define the areas that I'm going to track to generate that 3D camera. So when you're looking at this scene, you want to find the areas that are actually static objects and that don't have any motion on their own. So we don't want to track these characters here. We don't want to track the woman. We don't want to track the ocean because they're all moving on their own. We just want to track static objects, and that will give the camera tracker the information it needs to recreate this camera virtually. So we'll start off by defining those areas that we want to track. I'm going to go ahead and add a polygon by dragging it in from the toolbar. And the first thing I'm going to go ahead and define is these rocks here. I'm not really defining the tops of these palm trees here because they're moving a bit in the wind. And then as I click and drag this, I'm just creating a nice smooth curve here. I don't want any of the ocean because it's moving on its own. And so that should work for those frames. And then I'll just jump to the end of the shot. And adjust this polygon a bit by selecting all the points. And now that I'm closer to these rocks, this polygon's a bit too small. So I'm going to hold down S and click and drag, and that'll allow me to scale without having to actually manipulate each of those individual points themselves. I can actually do a similar thing with rotation. So I'll select just these points, and then I'll hold down T for twist, and I'll click and drag, and that'll allow me to rotate these points. I can also scale on X if I hold down X and click and drag, or Y and click and drag. So that works for these rough frames, maybe a little bit less on the Y-axis. And let's play back to see how this is looking. Okay, so we're drifting a bit, and then the camera pans, so I want to go to that point and adjust my polygon here. Now that seems to be roughly tracking how I want it to. Maybe one more keyframe in here. And that's going to work for what I need. It doesn't have to be exact. I'm just defining this rough area that I want the camera tracker to track. So I'm going to go ahead and name this tool by right-clicking and go to Rename. And I'm just going to name that Poly Rocks. I'm going to add another polygon tool. Instead of dragging in from the toolbar, I'm going to hit Shift Space and then type in polygon into my tool search pop-up. Now I'm going to define the beach. There's a little bit of overlap with the rocks. Adjust my spline here a bit. And I don't want to get too close to the water because I don't want to track the water. Okay, I'll jump to the last frame. Adjust this accordingly. A bit of scale here since we're closer. And a bit of rotation with T, click drag. All right, and let's see how that plays. I'll maybe add another keyframe more in the middle here to retain a bit more of this beach. Okay, that'll work. So we're looking pretty good here. The only issues we have with this is this character here runs across one of these polygons, and then these characters are running across the rocks. So I'm going to do some additional polygons to make sure that they're not tracked. So let's go ahead and start with the woman here, and I'm going to add a polygon with Shift Space to bring up the tool search, and then I'm already pre-selected on polygon, so I'll click Add, and I'll draw a real rough polygon spline around her. And instead of adding to these other shapes, I'm going to go ahead and change my paint mode in the inspector to subtract. And let's go ahead and view this tree real quick. You can see here that this polygon is actually subtracting from the other two polygons that I originally added. We'll go back to the plate and let me play forward and add a few keyframes for this character. Again, I'm going to use S, click drag to scale, and a little bit of additional refinement. We don't have to be too tight and exact with this, since there is quite a bit of good area that the trackers are going to have access to. One more keyframe for when she's out of frame. Okay, that should do it. And now I just need to add 2 more polygons for these characters. It'll name the ones that I already have done. Okay, so now that we've finished the polygon for the woman, we've got 2 more polygons to do, one for each of these pirates. So I'm going to add another polygon tool by hitting Shift Space and selecting the polygon from the search menu. And then for this one, I'm going to go to the last frame because the character is larger in frame, and so I need to add a little bit more detail to really define him roughly. So I'm going to go ahead and draw around this character, and I want to make sure that I capture his shadow, not just his body, because that shadow is really high contrast, and the tracker may actually track a point here, and that would be definitely a false positive. We've got that. I'm going to go ahead and play backwards, and right here he's basically moved pretty far off, and I'm looking for those high points of animation. So either where the character is furthest away from the rotospline, or they're too close to an edge, and that's generally when I need to add a keyframe. And as I'm adjusting this on these additional frames, Fusion is automatically laying down a new keyframe for this polygon. So So I'll play forward and I see his arm sticks out a bit here. So I'm going to go ahead and adjust this and add a keyframe. So that works for those frames. I'll play back a bit further. Yeah, I'll add one at the beginning and then we can just see where we land in the middle. So I'm going to really scale this one down a lot by holding down S and click dragging. And maybe scale down a bit on Y to get the top of the polygon a bit closer to his head. And give him a little bit more room to the right side of him. So let's play forward from here. Looks pretty good. Doesn't get too close to the edge. So I think we're good on that character. We'll go ahead and name his polygon by right-clicking in the inspector. I'm going to rename. And I'll name him Pirate 1. Okay, that leaves us with one more pirate. We're going to go to the last frame so we can capture all the detail around him. Meaning we have to add a number of points to actually fit this polygon to his shape. Again, we want to make sure we're capturing the tip of the sword and his shadow so the tracker doesn't lock onto any of those high contrast areas. That seems like another good keyframe because cameras move significantly farther away from him. I'm going to need to give him a little bit of room to the right of his hand. And I can probably tighten this up with a bit of a Y scale. I can even use this rotation on a single point like this. Sometimes I find it difficult to grab one of these control handles, so I can just hold down T and rotate by holding down T and click dragging. One thing to keep in mind when you're using those hotkeys is that the anchor point for the rotation is based off of where you're clicking with the mouse. So if I hold down T and I click out here, I'm actually rotating around that point, which isn't really what I want to do. I want to rotate around this point here, so I hold down T and rotate from there. It's looking pretty good. Oh, let me get another keyframe here at the very beginning and see how it interpolates. Our polygon's getting a little bit big, so I'm going to go ahead and scale it back down. Yeah, that should work for our purposes. I'm going to go ahead and rename this last polygon to match the others. And last thing I'm going to do is I'm actually going to view this polygon tree here to see what our result is. And you'll see I actually forgot to change the paint mode on these polygons for the pirates because we don't actually want to track these pirates, so we want them to actually poke a hole in the other mats that we've already drawn. So I'm going to go ahead and change the paint mode on the polygon for the second pirate to subtract, and the same thing for the first pirate. So now when we play back this whole branch, we're seeing just the areas that we're going to want the tracker to track. Okay, now that we've completed our last polygon, let's go ahead and view this entire branch to see what we have. Okay, and so what you can see here is we've got the rocks defined, and then we have the beach defined. So that's our rocks polygon and our beach polygon, and these are both overlapping. It's okay that they overlap because those are both areas that we want to be tracked. And then we have the woman's polygon that's actually cutting out a hole because we don't want to track her. And then we have this pirate. I actually didn't change the paint mode earlier, so I can change it now by clicking on that node and then going to the inspector and changing the paint mode to subtract. And I'll do the same thing for the second pirate. He's also overlapping the other pirate. That's okay, because we're just doing a very general definition of where these objects are, and ultimately the only purpose of that polygon is to subtract from the rock polygon and the beach polygon. So I'll set that to subtract. And now when we play this back, we're left with just the areas that we want the tracker to track in white and the areas that we don't want the tracker to track in black. So now that we have that, let's go back and view our plate footage. And we're going to add a camera tracker, which is our 3D camera tracker within Fusion. You can find that in the effects library under Tools, Tracking, and Camera Tracker. So we'll drag the camera tracker down into our main flow. And this differs from the other tracker, the main Fusion tracker, because that's a 2D point tracker. This camera tracker will create dozens or hundreds of tracks. And from all those tracks, it will derive the camera that was used to film the scene with its internal processing. And so these polygons that define the area that we want to track will feed into the camera tracker's track mask input, which is the gray input. So I'll just grab the output and connect it there. So now that we're feeding the mat for the information that we actually want to track, we're ready to really dive into this camera tracker and talk about how it works. So I'll hide my effects library. Now I've got the camera tracker selected, and in my inspector, there's a number of different things that we want to set up before we click auto track. First thing is I want to set preview auto track locations. And what that'll do is it'll show me the points that the tracker is going to track. Next, I'm going to change my detection threshold. As I manipulate that, you'll see that green dots appear on the screen. And actually, so I can make it a little bit easier for you to view, I'm going to go to the 3-dot menu of the viewer. I'm going to bring up my gamma gain controller. And what this does is it allows me to adjust the image. I'm not actually changing the image, I'm just adjusting how it's presenting. So now we can see all these green dots a lot better. So these are the tracker points that are automatically being laid down by the camera tracker. You can see as I adjust my detection threshold, those may change. Really, the detection threshold is controlling how much contrast the camera tracker is looking for to lay down a point. Then we have minimum feature separation. And the minimum feature separation adjusts how far apart each of these trackers needs to be. I want to have a lot of points to work with, so I'm going to go ahead and reduce the minimum feature separation quite a bit. Next on the camera tracker tool is the track channel. Right now it's set to Luma, which is going to work for our purposes. But let's say you had footage that had a very noisy blue channel. You may want to select a red or green channel to track instead. But in this case, Luma should work for our purposes. So then we have track range. Right now, we're going to track the render range. You can also adjust that to be global, valid. Valid is basically the valid range of that particular media in, or a different custom range. We're going to leave it to render range. And lastly, we're going to turn on bidirectional tracking. By default, bidirectional tracking is off, and what that means is that the tracker will track all these points while the clip is playing forward. Bidirectional tracking will actually try to extend all those previous tracks backwards in time. So this generally gives you a longer track, which will ultimately give you a better solve. So I generally like to have this option turned on. Lastly, we can talk about gutter size. Basically, that defines how close these trackers are allowed to get to the edge of frame. You can get false tracks if they get too close to the edge of frame. So if you need to, you can adjust this parameter to pull some of these trackers back from the edge of frame. I'm going to go ahead and just hit reset because this value should work fine. And I'm going to go ahead and reset my gain control and turn off that widget. And now that we've set up all these parameters, we're ready to click Auto Track. So what that does is plays the clip forward, and the auto tracker will follow all those features. And you can see here we've got our track points with blue lines that define the motion of that point. And if you hover over any of these points, you'll get some metadata about that, what the number of the tracker is, what the error is, etc., etc. So you'll also notice all these trackers are tracking just the regions we defined in white with all these polygons here. So that's exactly what we were looking to do. Now that we have some good track points, we can go to the next tab in the camera tracker tool. So we're going to go to camera. And here, what you want to try to do is add in all the information that you know about the real world production camera. So in this case, I know this shot was captured with the Blackmagic Ursa production 4K at 16:9. So I'll select that. And I also know the focal length is about 13 millimeters. So I'll adjust that there. And so that basically gives the camera tracker a hint to what the original camera was, which helps the camera tracker solve for the real world camera faster. So if you ever want to check to see if your source footage has any of the camera information embedded into it, you can click on the media in for that particular shot, view it, and then go to your subview button here. And so in that subview, there's a drop down, which gives you a number of different options. And if you select metadata, this will display all of the metadata that's associated with that source footage. In this particular case, we don't really have any useful information, but often there's camera information like focal length, ISO, time code, and other important things. So I can expand this box by just clicking and dragging the edge, and I can move around within the box by center clicking and dragging around. I already know all this information, and I already know the camera information, so I'll just go ahead and hide this subview. And let's come back to the camera tracker. Now that we've filled in all of the camera information that we know, we can go to the next tab, which is the Solve tab. First thing you want to do on the Solve tab is click Solve. The progress bar may get to 98% multiple times. Just give it time, and eventually that solve will complete. So in this case, the solve is now complete, and you can look in this area for information about the solve. Most importantly, you want to look at the average solve error. And in this case, we've got 0.3 pixels solve error. What that means is that for every point, there's an average error rate of about a little bit under a half a pixel. And that's a pretty good solve rate. You wouldn't want a solve error that was over 1. And generally, the higher the resolution, the larger the solve error you can accept. So for HD footage, anything under 5 is generally considered usable. If you do need to refine the solve further to get a better average solve error, there's a few ways to do that. You can find points manually that you think might actually be an error. So in this case, I'm going to delete this point because it's on the edge between this foreground palm and this background palm, so it may be a false positive. So I'll delete that. And in fact, these palm fronds move throughout the shot. So I'm going to select all these points and then delete them in the inspector. And you can play through the shot and see if any additional points pop up. I see a few that are, so I'm going to go ahead and go to those frames and delete a few of those tracks manually. You can also find some red trackers, and generally those are trackers that have a larger solve error. That track in particular is moving up the edge of that rock. And so what's probably happening there is there's a false pattern that it's finding between this foreground rock and this background rock. So I'm going to definitely delete that point. There's a couple other points here that are red. Let's see how those play. Those actually don't look like errors to me, except for this one on the bottom. this point on the bottom here ends up tracking the splash of the waves. So I'm going to delete that one. So that's one way to refine points. I'm going to hit Command F to go full screen. Another way to refine and reduce the number of bad points is to use your track filtering in the inspector. So if I adjust my track length, this is finding any point that has a minimum track of less than the number of frames that are defined here. Same thing for track error and maximum solve error. So I can adjust these parameters to identify the tracked points that don't fit these parameters. Select track satisfying filters, and then I can delete all of those tracks. Now that I've deleted some of these points that are maybe less high quality, I'll go ahead and hit solve again to see if I get a better average solve error. So our solve error just went from 0.3 to 0.25, which is great. The lower the solve error, the better result we're going to get. Now that we've completed the solve, we can move on to the Export tab. So the Export tab you use to actually generate your 3D camera and set up a 3D scene. Before we hit this Export button though, we want to go into the 3D scene transform. So what the 3D transform will allow us to do is adjust where the origin of the scene is, what the orientation of the scene is, and what the overall scale of the scene is. So to get started with these parameters, you need to change it from aligned to unaligned, and that'll allow you to change the 3D scene transform. So first thing I want to do is set the orientation to the ground plane. So I'm going to select a series of points that are on the ground plane, and then I'll set those from selection. So now the X, Y, and Z rotation now are going to match these points in setting our ground plane. Now, if you don't see a ground plane, let's say we just saw this rock wall or a building, you could set your selection to XY plane, which would allow you to set your orientation based off of a wall instead of a ground plane. But in this case, the ground plane works fine for us. Only thing I need to do now is set my origin. So I'm going to go ahead and go to the last frame, select a few of these points, and set my origin to here by saying set from selection. Now I'm ready to actually export and create my 3D scene. I do that by clicking the export button here. You'll see in the flow a number of nodes automatically get added, and I'll just move them to organize things a bit better. So the camera tracker has created all these nodes for us and basically set up our 3D scene. What we have here is the camera 3D node, which is our virtual 3D camera that matches the camera that was used to actually film this footage originally. We have a point cloud and a ground plane that we just defined. Those are all feeding into a merge 3D node, which is a specific node used in the 3D environment to combine 3D objects together. And then we have a camera tracker renderer node. And so what this will do is it will render all of the 3D objects using this 3D camera. So when we place a 3D object into this scene, it will match the live action footage perfectly. So let's go ahead and view the 3D scene by clicking on Merge 3D and pressing 2. So you'll see I go into Fusion's 3D environment, and as I drag around, I'm using Alt-click to drag around. I can see my ground plane's a little bit slanted here, which actually is fine because the beach is a bit slanted as well. So I'm going to be okay with that. I've got my virtual 3D camera that you can see here, and all of these points, this is the point cloud, and these points match the tracker points from the 3D camera tracker. So let's go ahead and play this through. You can see that this camera is moving through the 3D space, recreating the camera that was used to capture this footage originally. All right, now that we have our 3D camera, we can actually place objects in this 3D scene for final compositing. So let me go back to the original footage and do a little bit of organization in this flow. I'm going to go ahead and just move this camera tracker off to the side and connect this plate to my media out. I'm not going to actually need this camera tracker for the remainder of this project, so I'm just going to move it up to the side here. If I ever do need to modify anything, I can go back to this camera tracker later. Okay, so in this scene, I actually want to put a pirate ship here, a couple hundred yards off of the coast. So let's go to our media pool, and I'm going to grab that pirate ship and drag it in. First thing I'm going to do is name this element by changing it in the inspector. And now I want to place this pirate ship in that 3D scene. So what I need to do is actually put this image onto a 3D object so I can place it in the scene. So I do that by going to the effects library, and then under my 3D menu, I can scroll down to find my 3D section, and in there I have an object called Image Plane 3D. So I can go ahead and add that into my flow and connect the ship to the image plane. So what this will do is it will map the image onto this plane, which I then can merge into the rest of my 3D scene by dragging the output and dropping it over Merge 3D. And let's look at our 3D scene and see what we have. So if I can't see where this image plane is, because I'm too far zoomed out, I can click on it, and then in the viewer, I can click F, and that will zoom me in just to that object. And now I can rotate around, and I see my ship has been placed right where the camera's at. I want the ship to be placed very far in the distance, so what I need to do is push it further back in the scene. And what I'm going to do actually now is I'm going to switch my view to a top view. So I right-click in the viewer, I go to camera, and then I select top. From here, I'm going to zoom out by holding Command and then scroll wheel, and then translate by clicking my scroll wheel and dragging. And so I can see all my points. This is my beach, these are my rocks. So I want this image plane to be pretty far out in the distance. And if I'm not sure which object is the image plane, I can click off of that node and then click back on it, and now I can see where it is. So I would say these rocks are probably 50 or 60 yards from the camera. So I really want this ship to be pretty darn far away, maybe 200 or 300 yards away. So I'm going to move it roughly over here. So what's happening here is that the camera has a far clipping plane, which this ship is beyond, so that's why I can't see it. So what I need to do is actually adjust this far clipping plane. So I'm going to select camera, and I'm going to turn off the lock that's automatically on it, and then I'm going to adjust my far plane. So I've adjusted it out to 250 or so. I'm going to reset that lock, and now let's view our renderer. So I can see here that even though I've scaled up the ship, I can't see it. And what's happening here is my image plane is blocking the ship, and also my far clipping plane is blocking the ship. So the far clipping plane is where the 3D environment will basically end as far as this camera is concerned. It won't render anything that's beyond that point. So to adjust that, I'm going to go to Camera 3D, I'm going to disable my lock, and then I'm going to adjust my far clipping plane somewhere like 50, and so that's beyond the position where I put the ship. And then I'm also going to adjust my image plane as well by going to the Image tab and adjusting the depth of that. So now nothing should be blocking my ship. So I'll go ahead and set this lock again because I don't want to accidentally change this camera. And let's view the tracker. Okay, now we've got a ship. It's showing up and we can see it. So I've roughly placed it at the distance I want. I can also change where it's positioned on X and Y. So let's go ahead and adjust that a bit. Yeah, I want it roughly there. I think the ship looks a little bit big, so I'm just going to make it a bit smaller. Maybe 15 or so. Okay, now that I have that, let's go ahead and play this back and see how it looks in context. I'll make my screen a bit bigger. So you can see that this ship is tracking nicely in the scene. It's staying where it should. Size looks pretty good. Make it a little bit smaller and move it a little bit to the right, because at the last frame here, this character is crossing over it, and I'd rather not rotoscope him. So I'm just going to go ahead and adjust my X translation a bit, scale down a bit. And just to recap a little bit, I'm adjusting the image plane directly. I'm not doing anything to the ship. So this is just changing the position of that 3D object. I'm leaving the Z position alone because I liked how far I put it. And then I'm going to adjust my Y position. So it's right on the edge of all these waves. And let's see how that plays back. Cool, it's looking good. And on this last frame here, this guy doesn't appear to be crossing over, which is perfect. So we placed our ship in this 3D environment, and we're rendering that 3D environment, or rendering that ship through that 3D environment, and it's matching the camera's original motion because we did the 3D camera track that generated our virtual 3D camera here. So the next thing we need to do in this composition is we need to improve the blending of this ship. Right now, it's obviously way too dark. We could match the ship to the scene with a color corrector node, but there's a 3D node that can also help us achieve that look we're looking for. And that's called ambient light. So we can find ambient light under the effects library, under the 3D tools, and then light. So if I drag that in, this is going to basically create a light source that is going to illuminate any of the 3D objects. It's not directional, it's just an ambient light that's in the environment. So what I want to do is I want to connect that to my Merge 3D node so that it's part of this 3D scene. And I actually want to turn on my lighting in my renderer. So I select my renderer, and I go under lighting, and I want to enable lighting. So you can see immediately the ship becomes pretty dark. We can adjust that by adjusting our ambient light. So I'm going to go ahead and click my ambient light and adjust my intensity. It's getting pretty close, but I'm going to go beyond 1. Let me just jump it up to, let's say, 8. It's too bright. I can pull it back from there. And that's looking reasonable. Now I'm just relighting it a bit, but one thing about this ship, if we just view that asset on its own, is it looks pretty red and warm. The ship looks pretty warm. So when we're viewing the actual environment, it's pretty far in the distance. It should maybe look a bit bluer. So what I'm going to do is, instead of just lighting this scene with a white light, I'm going to change the tint a bit, and I'm going to drag this eyedropper over the sky here. And so that's going to give us basically a blue light to help illuminate this ship. So this is a before and after, before and after. It just tends to blend a little bit better with the background here. So the ship is in the scene. It's tinted just about right. The black levels are too dark for this. So I'm going to add a color corrector, this time actually after the camera tracker. So I'm going to do that by bringing up my tool search and finding color corrector. And now I can adjust my black point by adjusting the lift. But you'll notice that the entire scene is lifting. If I view this color corrector, you'll see that it's actually bringing up what was transparent. For the color corrector tool, you need to enable the pre-divide and post-multiply option under the Options tab. What this will do is it will make sure that your color correction is only applied to the areas defined in the alpha channel. So now that we've done that, let's view the merge node, and we can adjust our color corrector. So I'm going to bring up black levels. This is roughly matching the black levels of these rocks, which is great. And I'm going to adjust my gamma to get a little bit less contrast because the ship is so far away. I'll need to bring down my lift slightly as well. And so now I feel like I'm generally recreating the proper look because there's a lot of atmosphere between me and that ship. It would be a bit blue, a bit less contrasty, and so this is looking a little bit more realistic. So let's play back those results. That's looking pretty good. One thing I do notice though is that when I'm playing this back, the ship is very sharp even during this camera motion and these camera pans. What I need is to actually have some motion blur applied to this ship, and I can do that actually directly in the camera renderer. So if I go to the renderer for the scene, I can go to the Settings tab and enable motion blur. So let me actually, before I enable that, I'm going to go to a frame where there should be motion blur. Maybe right there where there's a pretty good pan. So I'll enable motion blur on the renderer. We'll see now we get some motion blur that seems like it'll probably match pretty well. I'm going to adjust the quality up to maybe 4. And what the quality does is it will draw additional versions of the ship. So if I draw this all the way down to 1, there's no motion blur. If I lift it up to 2, there's actually 2 images superimposed on each other. You can kind of see that up here. I get 2 additional images around the original. So I want to maybe bring that up to 4 so I get a nice smooth motion blur. The faster the motion, the higher the quality you need to go. I could also adjust my shutter angle if I know this is a 90-degree shutter or a 360 shutter. I'll leave it at 180 because that's pretty standard. So now when we view this playing back, we'll get a much better result because we have the blur baked in. So let's go ahead and view our results. And then we're going to jump to the edit page and watch them full screen. I'm going to jump to the edit page. I'm going to let it cache here for a minute, and then I'll loop that playback. Command F to go full screen. So that's looking pretty good. There's a few additional things we want to do to this scene, and that will illuminate some other parts of 3D compositing. So the first one, if I go forward a bit in the timeline, is we have some of the crew's footprints here. So a very common task in 3D compositing is painting out objects and doing cleanup, but in the 3D environment. So in this particular case, I want to paint out this footprint, but I need to have it actually mapped to the proper surface and track properly so it matches perfectly. I could maybe do that with a point tracker or a planar tracker, but often that's pretty difficult, and it can be even more difficult if it's a more complex shape like a barrel or the corner of a wall or something like that. So in this case, we're going to go ahead and paint this footprint out on this particular frame, and then we're going to place that paintwork on a 3D object that will then track perfectly into the scene. So the first thing we want to do for this kind of paint out work is we want to find a frame where this area is biggest in frame and it's also pretty much in focus with no motion blur or depth of field. This frame should work pretty well for us. And I'm going to start out this process by using the time stretcher tool, which you can find in the pop-up menu, or you can go to the effects library and miscellaneous, which has the time stretcher tool. So I'll drag that into my flow. I'll connect it to the original plate. And what the time stretcher tool does is it allows you to retime things, or allows you to freeze frame one of the sources. So in this case, I want to hold this frame on frame 71. So I'm going to go ahead and enter 71 into the source time. Now, if I view this time stretcher and I play back, all I see is frame 71. That's exactly what I want. So a bit of organization. I'm going to go ahead and move some of my nodes around to clean things up and to make room for this time stretcher, which I'm going to put down here. So now I want to paint this one individual frame. So I'm going to add a paint node from the effects library, the paint bin, and then I'm going to drag paint in. So there's several options to this paint tool. There is multi-stroke, clone multi-stroke, and stroke. I'm going to use stroke because that lays down a paint stroke that will apply across all frames. I'm going to change my apply mode from color to clone, and then I'm going to adjust my brush controls as I need to. I'm fine with this size, but I could make it a bigger brush, and I could adjust the softness of that brush, but I'm going to go ahead and just leave it at default. I want to view this tool, so I'm going to go ahead and load it into the second viewer. So using the clone tool is very simple. I've got this X in the middle, and I've got a circle around the outside that defines my brush area. Now I want to clone from this area and paint over here, so I'm going to hover over this part of the image, press Alt, and then left click, and that's going to lay down this X, which defines my source point. Now I'm going to move the brush over, and as soon as I click and start dragging, this X for the source is going to lock to that point and start painting the area from here over to where my brush is located. So as I do that, I can now start to remove that footprint. And if I want to change the position of this offset for the source and the destination of the paint, I can do Alt, click again to select a new area to paint. And now I've effectively removed that foot. So now that I've done that, I'm going to actually just create a rough polygon so I can just cut out this region, and I can use that to place in the 3D scene. So to do that, I'm going to add a polygon with my tool search menu and draw around the rough area where I laid down those paint strokes. Let me load that in the viewer, and I'm going to soften this edge a bit to just smooth the transition from the paint work I've done to the original footage. And to actually combine this alpha with this paint work, I'm going to use a matte control node, which I'm going to find through my quick search menu. And that's going to allow me to combine this RGB information with the alpha from the polygon. So I'm going to connect that to the foreground input of matte control, view that tool, and then change my mode from none to combine alpha. So that's basically copying the alpha from the polygon into the flow with the RGB data from the paint. Now I can still see some of the background there. That's because I have an alpha, but I haven't pre-multiplied the image. So I have to select Post Multiply Image. Now I have just the paint work and this patch of ground that I can work with. So one thing to note here is actually I'm on the edge of frame, and if I'm going to actually place this on a 3D object, I don't want to have a hard edge like that. So I'm going to actually adjust my polygon back a bit. Like that. And I'm going to reduce the softness a bit, because that's a little bit more than I need. So now I've got a nice soft patch here that I can have placed in the 3D environment. So to actually place this patch into the 3D environment, we're going to use a technique called reprojection. So what that does is we will project this patch through the camera on this particular frame, and it will project onto a piece of geometry, just like you would have a movie projector. So I'll get a little bit more into the detail of why that works and show you why that works. But just as an overview, that's the rough technique we're going to use. So to set that up, we want to actually project through our camera, our 3D camera, but only on this frame. I'm going to copy this 3D camera and paste it up here. And I'm actually going to unlock that copy of the camera, and I'm going to rename it. And I'm going to rename it to Cam FR71 for frame 71. I don't want this camera to be moving at all because this is from frame 71. I want that camera to stay put because I want my projector to stay put. So I'm going to go to transform, and I can see that there's animations in this transform because there's all these red diamonds, and I can see it in the timeline here. To actually freeze this camera on this frame, I want to right-click translation and then remove all, which is remove all keyframes from the translate group. And what that'll do is it'll keep the parameters for that frame, but remove all the rest of the parameters. And I'll do the same thing for rotation. Now I've got a static camera that I can use to project this image onto a piece of geometry. So I'll go ahead and drag this down here, and I'll connect the Mac control output to the camera as an image input. And a few other settings I want to adjust is I need to go to this projection tab. This is a new tab that just popped up. If I disconnect this camera again, I only have 3 tabs, but when I connect an image, I'll get additional tabs to work with. So I want to go to the projection tab, and I want to enable camera projection. So that turns this virtual camera into a projector. And I want to change our projection mode to texture. So what that means is that it will take this texture input and directly map that onto a piece of geometry without letting the scene's lights color that texture at all. So now I can connect this camera to my Merge 3D to bring it into the scene. And if we view the Merge 3D, so we're viewing the scene, we can see I've got my patch here and it's projected far in the distance, not exactly where I want it, but it is now in the scene. What I need to do now is actually place a piece of geometry for this projector to project onto. So what we're going to do is we're going to change our view from this perspective view by right-clicking in the viewer and going to camera. And then we want to view actually through the original 3D camera. So now we can see the scene as it was, but let me do this. I'm going to go ahead and connect my plate back to our main 3D camera so we can see what's going on. So you can see I have all these points on the distant rocks and the near ground plane, and they're a little bit too big, so I'm going to go ahead and click on the point cloud. I'm going to adjust the size down so I can see a little bit better what's going on. Okay, and for the time being, I'm going to go ahead and deactivate, or I'm going to disconnect this projection. There we go. So now I can see the footprint here. So what I want to do is I want to select a couple of these points, and I want to actually align a shape to this actual set of points. So I can do that. I can align a shape to these points by selecting them and then right-clicking, go to point cloud, and then I can create a shape, an aligned shape, or an image plane. And in this case, since I'm going to be projecting an image, I'm going to go ahead and just create an image plane. All right, and you can kind of see it there. There's a little sliver. I'm going to go ahead and go back to perspective view. And we can see our image plane was created up here, merged into our point cloud. I'm actually going to separate this image plane by shift, click, and then dragging. And I'll delete that extra merge. And I'll put this image plane back into the scene. So I can't quite see it, so I'm going to hit F to find where the image plane is at. And now I can see where it's at. All right, so I want to check the orientation and the size of this. It's a bit tilted back for my liking, so I'm going to go ahead and turn on this rotate widget and just fine tune the orientation of this plane so that it's aligned with the other points in the 3D environment. Okay, so that should roughly work. And I'm going to go back to the original 3D camera by right-clicking, going to camera, and then viewing through the 3D camera. Now I can see that that plane is a little bit better oriented to look like it's on the beach. I'm going to go ahead and increase that size by going to the Transform tab and scaling it up. So that way we have a nice large surface for this projection to land on. So the last thing we need to do is actually change this from a regular 3D object to what's called a catcher. So we're going to go to the Effects library, Tools, 3D, Texture, and then Catcher. And so basically this catcher texture is designed to catch image projections. So I'm going to go ahead and drag that in and attach that to my image plane. And now, instead of seeing this image plane, we will just see the images that are projected onto that image plane because of this catcher. So I can go back down to this group of nodes, which is where I set up that patch and that projection, that camera to project that patch, and reconnect it to the scene. And now I've projected that patch onto this piece of geometry. If I go ahead and go back to perspective mode, we can see that now that patch is mapped onto that piece of geometry, which aligns with this ground plane. So what that gives us is that when we play back this scene, you can see this camera here. This is the projection camera, and so it's always static, projecting that piece of texture onto that piece of geometry. All the while, the main 3D camera is moving through our 3D environment and capturing that patch as if it was stuck to that spot in the environment. So if we view that through our renderer, we won't see the footprint anymore. That footprint has been completely painted out. And actually, let me go ahead and disconnect our original plate from the main camera so we just see the objects that we've added. Oh, and one thing I forgot to turn off. So right here, you're seeing the projection, and right here, you're seeing something different. You're seeing the actual image projection. So by default, this projection camera also has enable image plane enabled. So I want to disable that, and now that disappears and I'm just left with the projection from that camera. So as I play through, I'm going to go ahead and pause on, this is frame 71 from which the patch originally came from, and it is mapped to that scene as if it was actually in this 3D environment. So if we look at that merged over the top, we'll see we're getting a pretty darn good result. Now this patch is too bright. What's happening here is all of our renders are going through this color corrector. So if I disable this color corrector, the patch actually looks correct. So what I need to do is constrain this color corrector to just the ship. So I'm going to create a very simple rectangle, move that over the ship, And this will give me a mask that will constrain the color corrector tool. So if I view the rectangle in the viewer, it's just a very simple mask. So now if I play it back, I'm going to get a much better result where the ship looks right and this patch looks right. And actually, if I look at this a little bit closer, I think this patch is a bit red early on, and then it matches better later in the shot. So what I'm going to do is I'm going to actually add another color corrector. Let me organize my flow a bit better here. I'm going to add another color corrector just for that patch. And I'll do that after the color corrector for the ship. And just to keep things clear, let me rename that color corrector patch, and I'll rename the original color corrector as color corrector ship. And I also want to do a rectangle to constrain this color corrector to just where the patch is. And like before, we need to enable pre-divide and post-multiply on the color corrector. And I'm going to go ahead and lay down a keyframe for gain and for color on this frame when this patch looks good. And I'll go back to the first frame and adjust things a bit on the wheel here to get this color a little bit more yellow. And I'm going to boost the gain slightly. To get something that's a little closer match. Okay, there's our before and after. That's looking pretty good. Now we can play through. It gets a bit red here still, so I'll go ahead and adjust that. There we go. So I've got a third keyframe, and that seems to blend pretty nice over time. Okay, so that's looking pretty good. I'm going to go to the edit page so we can play this back full screen and take one more look. So as we're playing back, it's looking pretty darn good. One last thing that I noticed that I think probably should be addressed is this is an American flag in this pirate ship. So a pirate ship's not a really good pirate ship unless it has a pirate flag. So let's go ahead and add that in real quick. And we can actually make that pirate flag wave in the wind a bit. So back in our fusion composition, I'll go to my media pool to find my pirate flag. I'll drop it into the scene. And I'll just work directly on this pirate flag for a couple minutes. Let me rename it to flag, and let's view that. So it's going to be pretty far in the distance. I think I can get away with all this color that's already built in, but what I want to do is actually change the color over time as if it's catching the light a bit differently in the breeze. So I'm going to add a tool called Fast Noise. So you can find the Fast Noise tool under Effects Library, Generator, and then Fast Noise. And what this will do is it'll create a noise texture that's static at first, and I'm going to go ahead and change it so it animates a bit by adjusting the seethe rate. And I'll adjust my contrast and my brightness a bit. I'm bringing the brightness down because I want some areas to be totally black, I want some areas to be negative, and yeah, let's see what we're looking at here. There we go. Now I've got some negative values. I just had to adjust that contrast up a bit. So I'm going to modify this flag by using a tool called Channel Boolean. And let me actually show you where that is in the effects library. Color bin. I'll drag that in. I'll connect the flag to the background, and I'll connect the fast noise to the foreground. And I'm going to change the operation from copy to add. Since some of our fast noise values are negative values, which if I hover my mouse and then you look at the bottom portion of the screen here, you'll see negative values, and then you'll see values that are above 0 and some values that are just about 0. What's going to happen is I'm going to add a negative, which will darken part of the flag, and I'll add values that are positive, which will brighten it up. So if I go to the flag and then we look at the channel booleans, now we can see some areas are brighter, some areas are darker. Let me hide my effects library. I do see a hard line here, and what's happening is my fast noise isn't the same resolution as my flag, so I need to change that real quick. So I'm going to click fast noise, go to image, turn off auto resolution, and then change my y-axis resolution to be the same height as my flag. And now I'm going to go ahead and just change my alpha. Instead of making some of the flag transparent, I'm just going to keep my background alpha. So now this operation is just affecting the red, green, and blue channels. So it's getting a little bit too bright, so I'm going to adjust some of these fast noise parameters to get a little bit better result. There we go. So let's play that through. Now we're seeing some lighting changes. Doesn't look amazing at this point, but it'll work later on, especially given how far away the flag is going to be. So the next thing we need to do is actually place this flag on a 3D object to place in the 3D scene. So we'll go ahead and do that with image plane. And then we'll add that image plane into our 3D scene by connecting it to the Merge 3D node. And let's go ahead and view the 3D scene. Again, if you can't actually find the object in the 3D environment, you can just select the tool and then hit F, and then it'll bring you right to that tool. Well, I know that I want this flag to be on the ship. So what I'm going to do is I'm going to go to my ship object here. I'm going to pin that. And what that'll do is that'll keep this node visible even when I select another node. So I'll select the image plane node for my flag. And now I can go to the transform tab and I can match some of these values to get this flag into roughly the same position as the ship. So I'm going to go ahead and put in a value of 14.5, 1, and negative 35. Oh, I missed my negative. And now if I hit F, looks like that flag is right roughly where the ship is at. So now I just need to use my on-screen controls here to put this flag right where the American flag is and change my scale and all the rest of it. So hit my rotation widget there, match that up, and again, I'm using Alt, center click, drag to orbit around, and just center click drag to translate around. Okay, we're roughly in the right position, but my flag is definitely too big. So let's scale that down on our image plane. So they should be big enough to cover the American flag, but not too big. Okay, we're looking pretty good. I don't want to intersect it, so I'm just going to pull this flag a bit off. That's looking pretty good. The one thing we're missing is this piece of geometry is just flat. What we can actually do is we can manipulate this geometry with a node called the Displace 3D node. So let's get that from the effects library, 3D tools, and Displace 3D. So again, that's under the effects library, 3D, and then the 3D tools, it'll be Displace 3D. And I'll drop that into the flow just after the image plane. And I'm going to actually connect my input to the fast noise. And so this fast noise texture will actually displace this geometry in depth. So let me do that. You can see right now it's very spiky. We don't want it that spiky. What we can do is go to the image plane here, Controls tab, and let me unpin that other image plane. And I can increase the subdivisions, and that's going to really smooth out. Let me zoom in there so we can see it better. That'll smooth out this displacement. So now we get much softer curves. Still, the displacement's a bit too extreme, so I'm going to bring down the scale. And now we're starting to have a flag that, if I play this, be waving in the wind, very roughly, something that would be effective because it's so far in the distance. One last refinement I'm going to do is this flag is actually going to be attached to this pole, so we don't want it waving at this far edge here. So I'm going to adjust the fast noise so there's no effect on this left edge. So I'm going to view my fast noise, and to do that I'm just going to add a simple rectangle. And connect that to the mask input of the fast noise. Adjust my size so it's not affecting any of the regions to the right. And it's just cropping off a bit here, and I'm going to go ahead and soften this rectangle. So essentially what's happening is we're going from zero effect. Let me just view one of the channels. We're going from zero effect up to having the full effect by about here. So the effect on the 3D object is there's no distortion at the very edge of the flag here. And then there is more at the end. And actually I can probably go a little bit more extreme with the soft edge. I just want to make my box bigger so I don't affect any of the other edges. And now let's take a look at that again. Yeah, so that's giving me roughly the effect I want. Now let's view it in the final composite. So now we've got the image comped in there. We can see our flag in the distance here. It's catching a bit of light there, but we can see it's still skull and crossbones. And let's go to the edit page to actually play this back. And now we have our flag flapping in the wind, and I think it's selling pretty well. And now we've got the final playback with the flag flapping in the breeze. And just as a quick recap, this is 3D compositing with Fusion within Resolve, where we use the 3D camera tracker to create a virtual 3D camera so that we could place our pirate ship into that 3D scene and also do some cleanup to remove the crew members' footprints and add a flag at the end that's flapping in the breeze. So thank you for joining me, and see you next time.